Hello, everyone. Good afternoon and good evening to everyone from wherever you are joining. It's my pleasure to host this session today. I'm excited to introduce our next speaker, Falk Mayer, co founder and managing director at BreachLabz. So, in his presentation titled Redefining OEM Supplier Dynamics, Powerful Thara Updates for Effective Requirement Specifications, Falk will dwell into how to address vulnerabilities in the automotive supply chain. He will explore the pivotal role of threat analysis and risk assessment across all the levels of supply chain, providing valuable insights into improving collaboration and security integration between the OEMs and the suppliers. So please join me in giving a warm welcome to Falk Mayer. So Falk, over to you. Thank you.
All right. Thank you very much, Sindhu, for the nice introduction. I would directly jump into the presentation if you don't mind. I'll share my screen. 1 second.
Yeah. So participants can please give us emojis if you're able to see the screen, and we also have a Q&A section. So please enter your questions in the Q&A. We will be able to take these questions at the end of the session.
Mhm.
Thanks.
Perfect. I see a lot of thumbs up, so I assume they can see the presentation. All right. Perfect. Then welcome to our Secure Our Streets talk. I'm very excited to give this presentation today, and I think we're going to have a couple of nice conversations afterwards discussing the topics that might be a little bit controversial today. Um, Today, I want to introduce myself very, very quickly, then go over the tower process in case anybody at this point is not yet familiar with it. Then we talked about a couple of pain points that we see on a daily basis when we analyze different towers from a penetration testing perspective. And of course, we'll provide some insights, some potential solutions with examples on how we would solve that issue, how we would address it. And then afterwards, we of course have to discuss for each of and every of those possible solutions, what are the advantages and what are the disadvantages of them. All right, I will jump right in. So it's very nice to meet you. My name is Falk. I am co-founder and currently managing director at BreachLabz. I've worked in consulting before, then have done many, many towers, and now I had the chance to go into penetration testing, which I like to call the fun part of cybersecurity, at least to me, because I get to play around with devices that other people have spent years engineering, and I can just spend all of my efforts to find certain flaws in them. All right, with that out of the way, let me quickly introduce the tower process again. I think everybody in the call is familiar with this picture. We take the item definition, which defines the system. Then we basically start our tower process. We go from the asset identification, which is the function or technical asset, however you define it, that you might want to protect. We have our impact ratings, which define the damage scenarios. So basically, what would happen on a vehicle level, on a component level, if my asset is compromised. And then I come to the threat scenarios and attack paths that exactly define how those damage scenarios might be achieved from the perspective of a cybersecurity engineer. This is more or less a theoretical exercise with the lessons learned from past penetration tests or from certain vulnerabilities that you have encountered and so on. And then we basically determine how likely are those attacks. We perform a lookup between the impact value and the attack feasibility, and that yields us our risk value. Depending on your risk appetite and how much resources you have available in order to introduce controls, you take your risk treatment decision and then basically start with the requirement specification from your goals, claims, and controls down in your cybersecurity concept. This is just to quickly get the terminology straight, because we're going to talk a lot about damage scenarios, attack paths, attack steps, and then potentially the risks. Just wanted to make sure that we have the same understanding, and then we can jump right into it. I'll already jump into the first pain points. So The main thing we're going to talk about today is ideas from our side on how to integrate the OEM and the supplier tower in order to make the process much smoother and to enable better collaboration and therefore better requirement specification at the end of the day. So the first problem is that we currently have is when we receive different sorts of towers from suppliers and from manufacturers, nobody uses the same template, but everybody claims that their template is probably the best out there. Um, but what happens is that, especially if you don't even share, for example, the Excel file or you share a PDF report, all of the information from the supplier tower into the manufacturer tower and vice versa has to be transferred manually. And this manual effort is really, really high, especially when you have iterations and when you have certain changes to your product during the product lifecycle. A potential, so basically this is exactly what I was mentioning. Everybody creates their own tower, and then in an ideal scenario, we would have our supplier tower and our customer tower, depending on in which relationship you are. You want to integrate them in order to make sure that your risk assessment that you have performed is comprehensive. But unfortunately, currently, we still end up having multiple files. And yes, they're going to be reviewed. Yes, they're going to be looked at, but they're not integrated together in order to also enhance further down the line. One potential solution that we have thought of, this is a mock-up we have created, is to use the supplier attack path as a single step in the tower. We deal often with the argumentation from suppliers that they don't want to share the tower in its complete state because it contains intellectual property. Right? I don't want to go into the discussion if this is intellectual property or not intellectual property. Let's just assume that the supplier does not want to share the attack path analysis in detail, so not all of the attack steps, which is perfectly fine, and this is just an assumption we can deal with at the moment. From a manufacturer's perspective, it would be still very nice to know what are the highest attack feasibilities that I have in my current tower process from the supplier. And I don't really have to take into consideration from a manufacturer perspective how this is achieved. Right? I trust my supplier that he has performed a reasonable risk assessment. I can perform an assessment, right? See that they have actually done what they have claimed. But at the end of the day, in my tower, I don't want to overcomplicate it. So why don't I just take the damage scenario? In this case, it's the compromise of the integrity of, for example, the left headlight. And all of the attack paths that have been allocated to this one damage scenario in the supplier tower can then be merged into your tower on the manufacturer's level. So basically, you would you classify the attack paths by the damage scenario, which you have because you have WISPs, and then you can just use them as one step in your attack path analysis. Of course, this has the precondition that you share the same tooling, that you have the same formatting, that you use the same values. So this can be aligned already in the RFQ phase. And of course, while joint development is definitely an advantage, you have to consider logistics, you have to consider different sorts of processes, on which levels are the tower performed, and so on. But this is still something we can implement along the way without sharing too much information, which is currently not the preferred option. The next pain point are the redundancies on vehicle level that are often not properly communicated or they're not taken into account because the cybersecurity engineer is very focused on how the system might be compromised. So let's take this example. In this example, we have a camera supplier and we have a LiDAR supplier. And both have brilliant cybersecurity engineers, right? They have fully understood the system. They have worked through all of the potential attack paths, and they say, you know what? If this happens, right? If my system is compromised, I'll hit a pedestrian, which of course has a severe impact on the road user, right? And we end up with very high damage scenarios. The LiDAR supplier, on the other hand, also says, if my LiDAR is compromised, I'm going to hit a pedestrian. Yet, if we take a look from the vehicle perspective, This is often not the case, right? We've been dealing with functional safety for years. And very, very rarely, especially for safety critical functions, we would not have some sort of redundancy implemented. So currently, both the LiDAR and the camera supplier assume that once the system is compromised, they hit a pedestrian. But this is actually not true. If, for example, only the LiDAR is compromised, right, and the perception layer that takes the decision at the end of the day on how the vehicle will behave, validates the information from the LiDAR against the one received from the camera. And if there is a mismatch, it will simply fall back to a safe state, and the driver can then regain control of the vehicle. So the assumptions that the supplier have taken because they didn't take into consideration certain redundancies have led to an increased risk in each of the supplier tariffs, therefore an increased amount of controls, and therefore, of course, contributed significantly to the cost of cybersecurity engineering, hardware development, software development, and of course, the validation at the end of the day. But how could we address this issue? First of all, we could theoretically, again, small mockup, again, left headlight and right headlight, and then on the right side, we have a front camera and a front radar this time. The idea is on a vehicle level, we have certain damage scenarios, as we had in the Hara already before. And we need to see which of the supplier damage scenarios need to be compromised, either one of them, as you can see on the left, or both of them at the same time in order to actually achieve that damage scenario on the vehicle level. So you can see on the left, if we say we have an arbitrary change in the brightness, right, we have an OR gate, this means that either the left headlight or the right headlight has to be compromised, but it doesn't really matter which one of the two, right? If both of them are true, still the same result. But now we move to the right side of the slide, and you can see that while the front camera, for example, has to be compromised at the same time as the front radar in order for the perception layer to, for example, decide, yep, I'm going to activate high beam. If this is not true, right? So if only one of them is compromised, for example, only the camera or only the radar, then we fall back to a safe state. And this is shown with this little false arrow on the right. So the idea would be that we also integrate safe states and redundant inputs already on the vehicle level. And if the manufacturer does not want to do that, of course, that would be the ideal case that the manufacturer defines those damage scenarios and does those redundancy mappings. We should still have sort of a collaboration that we can assume that we are not the ones from a supplier perspective that have to take all of the risks into account, but because we certainly have redundancies. Of course, as a consideration, the additional effort required by the manufacturer to communicate those redundancies and to manage all of the different suppliers is significantly higher. But yet again, it could lead to much cheaper components at the end of the day, to components that are much easier, that have a much more, how do you call it, acceptable risk appetite, right? They have considered an actual real-world scenario in a vehicle and then taken the decision how many controls they were implemented. All right. The next pain point is, of course, that the damage scenarios are not linked between the supplier and the OEMs. So, for example, that the lack of context, as I have mentioned before, yields that the implementation on the different devices is not well defined. And what that basically means is that if we could share, for example, OEM level damage scenarios, including the rationales, that would greatly benefit the damage scenario evaluation and the severity ratings. Because we do have some recommended ratings from our attack potential based approach in the tower. The problem is that if we have a lot of people in this call, and I would bet that if all of us did the tower for the same system, we would end up with very different solutions. We would end up with very different damage scenarios. We would end up with very different ratings. And therefore, we should sort of standardize this at least across the same car line. And this is basically, again, a point in enhanced collaboration and enhanced communication between the manufacturer and the suppliers. But yeah, then again, we run into the same issue that we've talked about before. How much information should we really share? What is considered intellectual property? Do you have how much of the integration context of the system you are supplying does a supplier really need to know? Because this is a very old cybersecurity concept, the need to know principle. And therefore, do you only need to know your redundant informations? Do you only need the damage scenarios that are allocated to you with the previous solution? So there's still a discussion to be had, but I think we can still figure out a good way. Then, of course, we have to have joint development activities, which increases the time spent on that collaboration. And then the level of abstraction in the damage scenarios need to be compatible between the OEM and the supplier. This could again be solved with the solution I have presented before, but if this is not taken into account, then we sometimes are not sure how to rate this damage scenario on a supplier level. And another pain point that we see is that widths are not allocated to architectural elements, right, from a manufacturer perspective, but they are usually allocated to assets, right? Even though it's sort of partially mandatory to trace down your width values throughout the different components, right? I mean, it's a recommendation in the standard. I think everybody sees it from the CAL perspective. We're basically assigning a certain initial width to this component, and then we would trace it down through all of our requirements, to our architectural elements, and so on. But the real benefit here is already in this OEM supplier relationship if this is done very early in the development. Because while this maintains a high level of abstraction, right, we don't look into the specifics of, for example, a supplier ECU. If the OEM can already define their width that they see for a certain supplier item, they can then allocate those widths better. And that's basically also the solution here. The allocation of the scope for cybersecurity development is very crucial because if the ECU, for example, we see this from a penetration testing perspective all the time. Yes, you have maybe not protected your debug ports properly, as a bad example, right? But yet again, you would have to have physical access to that ECU in the vehicle, and that takes a significant amount of time. Yet again, if the ECU supplier is not considering that and they have the ECU always in front of their table, and the pen tester does as well, we end up with very severe ratings. And yes, we definitely need to do this. And while it is a good practice to do so, we have to consider that in the context of the vehicle, those ECUs are sometimes not really accessible. Right? Or you would have to perform a lot of effort and disassemble the vehicle, be alone with it for extended periods of time and have all of the equipment available. So this becomes very unlikely, and therefore those become lower risk solutions. Something we have to consider here as well is, first of all, we have to have the awareness of all the different architectural elements. So we basically need to allocate those risks to the suppliers. So we can only do that once we have a certain level of certainty in our architecture from a manufacturer's perspective. And of course, it's an additional effort and an investment upfront already in the concept or development stage in order to do that properly. The next point is sort of related to this because from the process of how an OEM communicates his requirements to a supplier, there can be differences here, right? So we have, for example, in this example, we have cameras. And cameras can fulfill very different use cases. Yet again, we sometimes see that no matter what the use case for the device is, the requirements that are allocated in an RFQ, for example, or later from the OEM, they stay the same, right? Because it is a camera, and a camera has to be protected in a certain way. Yet again, if the camera fulfills a different purpose, or the camera is mounted differently in the vehicle, the damage scenarios and attack feasibilities, right, and therefore also the risks allocated to those different components are very different. And therefore also the set of security requirements are very different. If we take a look at the example below, on the left-hand side, we have a driver monitoring camera, and on the right-hand side, we have a rear view camera. Well, a rear view camera is, for example, very crucial for certain, for example, autonomous driving features or certain lane keeping assistance and so on. We have a certain need for the availability and a certain need for the integrity protection. Those are our main goals, right? Because it's always pointed to the rear. We don't really have any personally identifiable information to deal with. Yet again, on the driver monitoring camera, this is exactly what we have to deal with. Because since the camera is pointed inwards and is pointed at the driver and at everything that happens in the vehicle, we need to take confidentiality into consideration as well. Therefore, while we would, for example, from a control perspective, from a requirements perspective, for the rear view camera, we would rather go for something like message authentication, some sort of message authentication codes, and so on. On the driver monitoring camera, we have to make sure that those camera feeds, and especially the storage of the camera feeds on the drive, are properly encrypted to prevent unauthorized access from reading them. And this is also what we talked about there, that that we have to have a tailored information in order to not go into unnecessary resource investment and a broad scope of requirements. So by allocating those elements, as we have talked before, right, we could save a lot of development effort here. To illustrate this a little bit better, I have sketched out a well-known approach and then a little bit of a step further. So let's start with a well-known approach. First, we evaluate all potential attack vectors. We see our risk value and take a look, is our risk too high? No, perfectly fine. We accept the risk and then assign the requirements to the requirements catalog. If the risk is too high indeed, we assign a control, we perform another iteration, see if the potential attack vectors have changed, see if the risk has changed, is it sufficiently low, then we assign that control to the catalog. But what if we, for example, go one step further? What if we say, for example, that this very component that we are looking at, that we have allocated in the architecture, is in my current attack path? Right? And then again, is this attack vector that I have allocated to my step, is it also linked to my component? Only then the control really has to be allocated to the supplier and therefore to the added to the requirement scope. Of course, more granular supplier management is required, and I'm happy to discuss all of those considerations later with you. Yeah, and then we basically come to one of our last points, and that's the handling of transfer and sharing claims. So as you know, right, we have basically, I think, 4 different risk treatment measures. We have retention to accept the risk, we have mitigation, and we have transfer and sharing. Transfer and sharing are 2 very interesting things to do because they require the supplier towers and the OEM towers and other supplier towers to be properly synchronized. So for example, if we take one supplier that can't address a threat they have analyzed with a proper security measure themselves, they might reach out to the OEM and say, could you please take a look at this? I think everybody has heard this phrasing, due to more effective mitigation measures being outside of our scope. And then the OEM can say, yes, this is probably reasonable because we are responsible for the wiring harness and we know where to route it. So therefore the access to it is on our side. But then what if we push it to a connected ECU, right? Then there's no guarantee that this transfer or sharing claims are properly then distributed to the actual supplier that I pushed it to, or even handled within the manufacturer. So this illustrates the point a little bit better. We, for example, see we have ECU supplier A, and ECU supplier A has a problem. Then they talk to the OEM, say this is perfectly fine as long as you accept this transfer of our risk because it's outside of our scope. Then the OEM would have to go to ECU supplier B and then basically apply it. But yet again, this communication is not perfectly happening yet. And a potential solution here would be to have a transparency platform that is managed by the manufacturer and enables just the sharing between suppliers of certain threats, right, and of certain risks that might not be effectively handled in their own scope. Of course, we have to consider here that the introduction of transparency comes with a certain couple of drawbacks. They require a lot of joint agreements, they require strong NDAs, right, and a lot of management overhead at the OEM. And of course, in order to establish such a platform, the resources have to be invested in the first part. All right. My last point is that something we see on a daily basis, and we don't complain much because we're a penetration testing company. So if the amount of money that has to be spent on penetration testing is higher, we are basically profiting from that. Yet again, it's something that is not really sustainable, especially in the long run when we develop more complex ECUs and we have the software updates that we have to test and so on. So the problem that we see is that even though ECUs share a lot of context, especially communication lines, and the amount of testing that goes into it and the test scoping is not taken into account across different ECUs. So it's always retested without considering what already has been tested on another ECU. Right, and then the idea would be basically that that the scoping has to be aligned with the manufacturer first, which is usually already the case, and then the manufacturer that has the overview of all the different ECUs and their testing scopes can then, for example, say, okay, there's an overlap, so you don't have to test your communication line, for example, if it implements everything properly. Yet again, this could also yield another benefit. If we, for example, have very strong requirements on a certain communication line, we could have it tested by two independent penetration testing companies, and therefore have more certainty that nothing has been overlooked. Of course, this requires a strong alignment, right? And the test results have to be shared in order to avoid redundancy. But then again, there's always the question of intellectual property, and this is something we have to take into account. All right, I quickly ran over those. So thank you for your attention. I hope everything was clear and you got some inspiration. I'm looking forward to the discussion.
Yeah. Thank you so much, Falk, for the interesting insights and also talking about the real problems, what the OEMs and the suppliers they
Mhm.
deal with. And yeah, we moving on to the next session of Q&A. We have a lot of questions, so I'll be showing one by one question on the stage, and yeah, maybe we can address it. Yeah. Okay.
Absolutely.
Moving on to the first question. For supplier work on out of context component, lack of a specific OEM, how it can consider such redundancy within its own Thara?
That's a very good question. Fantastic. Actually, because we have also considered that already, and those are assumptions that you can build yourself when you build an out of context development, right? An out of context platform. You assume a certain integration context already, and then you have to validate it once you move this to an application project. So you basically take this whole tower that you have performed for the platform and then shift it over to an application project where you change the scope and can therefore also change the damage scenarios. Does that answer your question?
Yeah. So I think you can give a thumbs up in case if it is addressed, or you can raise a follow-up question. Thank you,
Okay.
Falk. So then moving on to the next question, I think I'll skip my question to the last. So yeah, uh, are there any unknown methods to get consistency in feasibility ratings assigned by the different engineers?
Um, yep, I think this is something that everybody tries to address, and I think the best way I've seen so far is to have attack path catalogs. So certain attack path catalogs that are already weighted on a per step level, and then depending on which sort of attack path you're considering and amount, and you already have a predefined set of ratings, and then you just can take a look at that, and then once you start expanding, you would just use very similar ratings along the way.
Right. Yeah. So moving on to the next question. I think to define or standardize and share the damage scenarios for a particular vehicle type by the OEM and then to pass to those of tier 1 is a great idea. Why didn't it happen in the automotive yet? The intellectual property reasons or maybe others?
Well, first of all, thank you very much. I am wondering the exact same thing. Currently, there are a lot of discussions, especially in the SAE rounds as well, on defining a joint scope of what to share. But then again, I think intellectual property is still one of the major factors that people are afraid of.
Yeah. Yeah, moving on then to the next question. So,
Mhm.
how can organization, OEM, and supplier ensure that the requirement specifications are comprehensive, consistent, and traceable in the context of thorough updates?
Yeah, excellent question. I think that was perfectly relating to one of the pain points I was mentioning. Once you start allocating the widths to certain architectural components, those widths on the OEM level are basically automatically traced down to the supplier. And since when you integrate also the supplier attack paths into your damage scenario ratings, your risk on the OEM level changes once the supplier changes its tower, right? And also for the supplier, its risk value changes once the OEM changes its tower. So as long as those are still linked and we have the exchange format defined, I think this is perfectly reasonable to do. And of course, we trace down from the tower to the requirement specification. So I think that should be straightforward.
Mhm. Yeah, thank you. Then, yeah, the next question. So, yeah, during HARA, which is performed according to the ISO 26262 functional safety and automotive safety integrity level, a ASIL is assigned to an system. The most critical level, ASIL D, can be assigned as ASIL B through redundancy. Is it similar for Thara?
Yeah, exactly. That was the point I was trying to make with the pain point of introducing, so to consider those redundancies. This is something that I haven't seen in a lot of towers being considered yet, but I would strongly suggest that we start doing that because from a penetration testing perspective, I don't know how often we have compromised a single system in a vehicle and wondered why it didn't have the effect that we had on the that we expected on the vehicle. And the answer is simply redundancy. So we should definitely start considering the exact same thing here in order to also bring down our risk levels. So yeah, fantastic description as well. Thank you.
Thanks, Falk. And hope it has been addressed. And now the next question is about there is a very strong link in the SFMEA and DFMEA with the failure mode of higher level becomes the failure effect on the lower level. So how do we do it on Thera?
That is an excellent question. I think it describes, please correct me if I misunderstand the question, but if we integrate all of the potential attack paths, right? To us, basically failures are certain attack steps that have been performed on attack paths. In cybersecurity, we would basically um, allocate all of the potential attack paths that have led to a certain damage scenario, which is the failure at the end of the day, right? And then we could consider them in the OEM tower as a single step because we just inherently at the level of the OEM can then calculate across all the different permutations that you have, and therefore we will consider all of the different potential um, failure, how do you call it, safety failure chains, failure. Maybe you can help me out there. I think I'm missing the right terminology, but yeah, I think the message got
Chain.
across. Yeah, perfect. Thanks.
Okay. Yeah. Thank you. I hope it has addressed the point. Yeah. So coming to the next question. OEMs, tier ones or X are hesitant to mutually share the thorough details. The OEM who is having the vehicle view can make the necessary decision based on thorough reports from the tier one. How can the current status quo change? I think it's a lot of insecurities or intellectual property. So how do we
Yeah.
address this problem? Yeah.
Again, I think this is an excellent point, and I think this is what we are struggling with as well. That's also the point of this presentation. The amount of so of course we don't want to assume that everybody shares everything because this is the status quo. That is not going to happen. So what our suggestion would be, at least our idea, is that through the limited amount of scoping that we have talked about, for example, just showing which systems are you redundant with, right? And not showing you exact attack steps, but a collection of the attack path, but feasibility ratings that are allocated to a damage scenario, you can severely limit the amount of insights into what the other party can see. Because normally speaking, at least from my personal experience, the only thing that could potentially have confidential information is the attack path analysis for the attack steps. And since we eliminate sharing the attack steps specifically and just share joint ratings, we could omit this problem altogether.
Mhm. No, I think that's a wonderful point. So that how do we collaborate to solve a common
Mhm,
problem altogether? Yeah. Okay. So moving on to the last but one question.
mhm.
Is it possible to limit the scope of penetration testing by contractual means to safeguard the intellectual property of suppliers?
Okay, that's an interesting question. I think the contractual means to safeguard intellectual property of suppliers. Um, So my understanding, the usually the supplier themselves hire the penetration testers, right? So I think that's perfectly fine. And the report is only shared as an excerpt with the manufacturer, just the open issues. But if the idea is that we perform the penetration test on the vehicle level and the manufacturer should not get the insight into the workings of a supplier unit found in the penetration test, I think this can be mostly mitigated by having an independent penetration test performed by the supplier already, because then the OEM will save on the budget to have your specific unit included in the pen test, right? Because they have already have a report and therefore can show compliance already for that unit. I've not seen any contractual means though. I think that is an interesting point.
Mhm. Yeah, I think having an independent pen testing would be giving a real black box testing for us to see which are
Mhm.
the possible attack paths and the possible areas where it is more vulnerable. Okay,
Absolutely.
so moving on to the last part of the question. So, as requirements evolve due to thorough updates, how should OEMs and suppliers adapt their contractual frameworks and governance structure to balance the agility with accountability?
Mhm. I think this is a very nice question because this basically goes into the direction of real-time tower updates and information sharing to a certain degree, right? We have the OEMs that basically, whenever they perform certain changes to the towers, have to communicate those changes very, very quickly, and it's an official change request. If we are too late in the development cycle, we already have the contractual agreements in place. But I think that the connection between the cybersecurity engineering and the change management process is being developed all the time anyways. So maybe it depends on if we take a look pre-SOP or after SOP, right? Because I think this is a very big difference, especially with the amount of changes that we can still do to the product. I think pre-SOP this is a regular change request, and after SOP this is probably the same contractual obligations that we have from incident reports, for example.
Yeah, yeah, I think yeah, it answered my question. Also, I think
Very nice.
giving us giving us more insights about how do we treat that as a complete vehicle topic and not like OEMs or suppliers. So, but at the end, how do we safeguard the products?
Mhm.
So with this, we come to the end of the session. So in case if you have more question or would like to talk to the speaker, he might be available in the launch for some more time. So in the stage one, you can talk to the speaker. And thank you all for joining. And thanks, Falk, for giving us interesting insights and coming to SOS 2024.
Thank you so much for having me, and thank you everybody for joining.
Yeah, thank you.
All right. Thank you.